What's up guys, this is Jared with Renaissance Coders, and today I have a pretty cool project for you. I recently played through the newer God of War game and I absolutely loved it, so if you get some time, you should definitely check it out. While playing through the game, I found myself fascinated by the Leviathan Axe, which is the new weapon that Kratos uses in the game. I was really interested to see how the axe worked, and I wanted to try and create a prototype version of the axe using Unity. Now in this video, we're going to explore creating a rough alpha version or a prototype of the Leviathan Axe. So basically we're just going to be getting the bare bones of the axe implemented, like the throwing and the returning, and getting the axe to stick places. But I still think the final result is pretty cool, so definitely be sure to watch this video in order to learn how to do this yourself. Okay guys, so that will do it for our quick introduction to this video. Now let's go ahead and actually take a look at the final product before getting started with the creation of this project. Okay guys, so this is the final project that I have right now. As you can see, all it is a basic level. I've just got some walls set up, I've got a floor set up, I've got the rigid body FPS controller set up with the axe that we're going to be using childed underneath of the main camera on the rigid body FPS controller. And if I press play, we can take a look at it real quick. Obviously, I can look around just using the mouse. I can walk around pretty easily, again, just using WASD. All pretty basic Unity stuff. I can also throw the axe with the left click and recall the axe with a right click. I can, of course, aim up and throw it a little higher, or I can recall it when it's farther away, things like that. I've also got it set up so that I can throw it and hit like the floating orb there and recall it from there. And also throw and recall while it's midair. Obviously, there's a little bit of a bug right there that you just witnessed. Basically, what's happening is the axe is not returning all the way, or it thinks it's returned all the way, and it actually hasn't. So let's see if I can get it to do that again. Just throw, recall. It happens every once in a while, and I think it has something to do with the way it's lerping. The other thing I can do is obviously throw the axe, move around, and recall. Of course, when I do that, you'll notice that it's actually jumping. You have to have a pretty quick eye to notice it, but it's jumping at the last second. If I sprint, so I throw and then I sprint, it's a little more obvious. So that time you probably noticed it jumped probably about 3 or 4 feet, maybe 5 feet to the player. And that's what we're actually going to be creating in this video. So I'm going to go ahead and stop this, and I'm going to go into a fresh scene. So to create a new scene, just right-click Create Scene, and we'll just call this Video Scene. And now I'll go ahead and actually open that up. Okay guys, so here we are in our new scene. Before I actually do the level design here, I do want to point out that we need to pull in a few packages in order to actually create this. If you go into Assets, Import Package, then you need to import the Characters package and the Prototyping package. The Prototyping package is not necessarily needed, but it does help you create levels pretty quickly, and we're just going to create a fairly bare bones level, so having a prototyping package here will definitely help us out. Now, the other package that we actually need to import is the Axe package from the Asset Store. And don't worry, it is free. So let's go to the Asset Store. And as you can see, I've already got it pulled up here, but in order to find it, all you have to do is go to the search bar and type in Axe. And you can see it here, Axe Fairy Shop is the creator, but if you press enter, then it will load up all of the axes available to us. Obviously, there are several other axes out there that you could choose to use. Some of these are free, some aren't. I just really liked this one because it actually reminded me a lot of the Leviathan Axe from God of War. So just go ahead and click on it and import it into your project. Okay, now that we've got everything actually imported, what we want to do is go ahead and design our level. Now, all we really need is a floor and something to throw our axe at, and it could even be thrown at just the floor if we wanted to. I'm actually going to add a few walls just to make it a little bit prettier, but I'm probably not going to polish it up as much as my previous scene. So I'm going to fast forward through this because this is not what's really important here, and for the sake of time, it just helps to fast forward through the level design process. So let's go ahead and get started with that. Okay, there we go. Now we have a very basic level designed for us. Of course, if I click on the wall and zoom in on it, we can see that our grid is a little bit askew right now, but that's not a huge concern for me at the moment. The big thing is that we do have a level that we can actually play around with. Now for the next part, we're going to go ahead and build out the player and the axe and all of the game objects that we are going to need in order to actually get this working before finally finishing up on the scripting. So next step is pulling in the player. Okay guys, so now we are at a point where we can start pulling in our player and building out the objects as needed around the player. So the first thing I'm actually going to do is I have a prefab of my previously created player, so I'm going to go ahead and drag that prefab in. You don't have to do this because obviously you won't have this prefab, but I'm going to keep it there just to make sure that I maintain some values from my previous setting. So now that I've got my example that I can reference throughout this video, I'm actually going to go ahead and go to the standard assets folder, then the characters folder, first person character, and prefabs, and now I'm just going to drag in the rigid body FPS controller here. Now, as you can see, when we drag it in, it's about halfway through the floor because the center point is at the mid height of the object there, so we can just drag it up a little bit. So then on start, it's going to drop down and collide with the floor. The other thing I want you to notice is that it's rotated 180 degrees in the Y. So when we start, we're actually going to be looking at negative Z, or looking down the negative Z. So you can see that our global directions here, Z would be going in this direction, as you can see by this arrow here. And if you look at the global versus local, our character is going to be facing basically backwards at the start of the game, which isn't really a huge issue, but it does bug me a little bit that it's got this rotation on it. So what I'm going to do is just remove this Y rotation, and now our character will be facing forward, which is exactly what I want. Okay, the next thing we need to do is actually pull in our axe model. So I can go to the assets folder and then the axe folder here and just pull in the axe. Again, once you look at this, you'll notice that it is at a weird rotation angle, and you'll notice that neither one of these actually has a rotation applied to them. So if you look at the parent, there's no rotation applied, and the child has no rotation applied. So basically what this means is when the axe was imported, or when the axe was created, it was created at this angle so that the face of the axe was looking down the x-axis instead of the z-axis. Now, this is actually pretty easy to fix for us because we do have that parent object. We can rotate the child object so that it is looking forward. So this should be, I believe, 90 degrees in the Y here. Yep. So just 90 degrees in the Y on the child object, and now the axe is facing the correct direction. Now, an important note I want to make here is that it's really only advisable to do this if you have a child object. So if the model is on the child object. If you try to do this on an object that has a model and is not a child, then you'll run into a lot of issues a little later on when you're trying rotations and things like that. Because if you look at this right now, our local coordinates are basically 90 degrees off. So our Z, instead of going forward, is pointing to the right, and our X has basically become our Z. Now, it's not going to be a big issue for us because we have this parent object, and we can do all of our manipulation on this parent object, which does have the correct coordinates on it. Okay, the next thing we want to do is actually move our axe underneath our main camera. As you can see here, I have two main cameras, or actually three, because I have two rigid body FPS controllers, but I'm just going to delete the one that's currently there in the scene. And if I toggle down on my rigid body FPS controller, there's a main camera under here. So I'm going to go ahead and move the axe underneath this main camera. And now if I click on the main camera, it shows me a preview, but we're really not seeing the axe in a very desirable position. Let me go ahead and turn this guy off so it's not in the way. So as you can see, the axe is like down and to the left of the main camera. So what I'll do is click on this axe, and I will reset the position, which is going to move it to the parent object's position here. And now if I click on my main camera, we can see that obviously we don't see the axe, and that's because the axe is behind our fall off or clipping planes there. So what we want to do is actually move the axe forward and to the right a little bit. So it's a little bit easier to do this if you have your game and your scene view open at the same time, so that you can just drag it forward. Oops, I'm still on the camera. So you can just click on the axe and drag it forward a little bit, and then to the right a little bit, maybe forward a little more, to the right a little more. And now if I check just the game view, I can see that it's still not quite far enough ahead. So what I'm actually going to do is, just to speed this up, I'm going to copy the values from my other axe. So I'm going to go under my initially created one, and it looks like I've got 454. So I was pretty close there. 0.454 and negative 0.037, very slight decrease there, and 0.889. And I'll be sure to show those values on the screen here in case you can't see those. And of course, if you want to try some different settings there, with it being higher or lower or anything like that, you can certainly do that yourself. That's totally fine. The big thing I will point out is that your axe has to be high enough so that it's not going through the ground, because we are going to be using a collider and things like that, so that may cause some issues. So you can see your rigid body right now. Just make sure that your axe is kind of above this, the bottom of your collider on the player. Okay, the next thing we actually need to do on our player setup is add an empty game object under our main camera. So we'll right click on main camera, do a create empty, and we're going to call this our axe pause holder for axe position holder. And now I'm actually just going to click on my axe. I'm going to copy the component here, and I did that by clicking on this gear icon, copy component, and I'm going to paste component values here. What that's going to do is move it to the same position that the axe is currently positioned at. So basically what this is going to do is it's going to hold a point for our axe to actually return to. So when we call the axe back, it needs to know where it needs to go, and this position holder here is going to be the point at which it returns to. Okay, so we have a little bit of setup left to do. What we need to do is add a rigid body and a collider to our axe. So I'm going to go ahead and just add a rigid body here. So we're going to do rigid body, and we don't have to play with any of those settings now. And I'm actually going to use a box collider for this. We could use a mesh collider, but I actually ran into several issues with the mesh collider while testing, so I found it was easier to just use a box collider that is only containing the blade of the axe. And it's actually pretty easy to get it around just the blade of the axe. If you do edit collider here, then you can play with these little points here until it's just surrounding the axe head. So now let's move it around. Move it up a little bit. I just barely want to contain the blade of the axe. I'm just going to move it forward just a little bit. Okay, that's going to do it for all of our setup. We should be completely done with the setup now. Of course, we do have the scripting left to do. So in your assets folder, go ahead and create a scripts folder and enter into it. As you can see here, I already have 3 scripts created from my initial testing, but we're going to go ahead and create 2 new scripts here. The first one's going to be called axe. So right click, create a C# script and just call it axe. And the second one is going to be called axe collisions or new axe collisions. So I'm just going to create another C# script that I'm going to call new axe collisions. Of course, you can just call yours collisions. I actually misspelled that. Let me change that really quickly. But of course, you can just call yours axe collisions. Obviously, I can't call it the same thing because then I would run into errors inside of Unity. So the first script we're actually going to work on is the new axe collisions or axe collision script. So let's go ahead and open that guy up. Okay, so the first thing that we can see here is obviously my misspelling carried over. So I need to change that first. We are going to be using the start function, but we don't need the update function. So we can go ahead and get rid of that here. Okay, so let's go ahead and set up a couple of public variables. We're going to need a public rigid body that we can just call RB, and we're going to need a reference to the axe, so we're going to say public axe. Now inside of our start function, we want to make sure we get the rigid body, so we're going to say RB is equal to get component rigid body. Obviously we have to get that component in order to actually do something with it, and looks like I misspelled component. So we're obviously going to have to get the rigid body in order to do things to it. So that's why we're setting that up inside of the start function. The next thing we're going to do is use the void on collision enter function, and it takes a collision that we can just call collision, lowercase c. Okay, so the first thing that I actually want to do inside of this on collision enter function is call a function from the axe script. Obviously we haven't implemented the axe script yet, but I will cover what the function does once we do that. So in order to call the function, we're going to say axe dot collision occurred. So when we create the axe script, we want to make sure to create this collision occurred function. The next thing I want to do is set rb.use gravity equal to false. I'm setting it to false because we don't want the axe to fall after a collision has occurred. So basically what's going to happen is the axe is going to be moving forward after it's thrown, and once it enters into a collision, we want to turn use gravity equal to false, so that way it doesn't enter the collision and then immediately fall to the floor. The next thing that I want to do is set rb.isKinematic equal to true, and isKinematic will say whether physics has any effect on the rigid body or not. So if it's set to true, then that means that physics will not have an effect on the rigid body. So again, this is just ensuring that the axe stays where it is after the collision occurs. The last thing we're going to do is call another function that I'm going to call add constraints, and we don't have to pass any parameters to that. Now we need to go ahead and define our add constraints function. So to do that, we're going to say void add constraints, and inside of this we're going to say rb.constraints is equal to rigid body constraints dot freeze position x, then make sure you use the pipe, and we're actually going to go ahead and copy all of this and just paste it one last time, delete the final pipe there, and the second one will be rigid body constraints dot freeze position y, and the final one rigid body constraints dot freeze position z. Okay, so what this function basically does is it adds the freeze position x, freeze position y, and freeze position z booleans equal to true for our rigid body. And this is again making sure that when our axe enters into a collision that it is actually freezing its position. Notice we're not freezing the rotation here because it's going to stop moving entirely, which means that it should no longer rotate. But we're going to handle the rotation in the actual axe script as well. So the final thing that we need to do inside of this script is remove the constraints under certain circumstances. But we're going to actually remove the constraints from the axe script, but we do need to go ahead and define the function now. So again, we're just going to add another void, and we're just going to call this one remove constraints. And we can of course just copy this remove constraints equals here just to cut down on time a little bit, paste it, and we're going to set rigid body constraints dot none. So this is going to remove all of the set constraints on our rigid body, thus allowing the rigid body to move again. Okay, now let's go ahead and save this script. Go back to Unity. Looks like we do have, okay, that's an issue because we're calling it from Axe, and Axe doesn't exist yet, but we're going to fix that in just a second. Now let's go ahead and open up our Axe script here. Now, we are going to have a lot of variables that we need to set up initially, and I'm going to try and cover them as best as possible, but let's go ahead and just dive into them. The first thing we're going to need is a public game object that we can call Axe. We're going to need another public. We're going to call this one our rigid body, and we can call it Axe RB, or just RB again, if you would like to. And we're going to need a public game object for our position holder that we can call Axe temp holder, or Axe pause holder, either one. And these are all references that we need to have in order to actually manipulate and move around the axe based on input. Now we're going to set up a couple of variables that we need to handle the axe's movement. So let's go ahead and underneath this, we're going to create a public float for axe flight speed. And we're just going to set it initially to 10F. We're going to need another public float for axe throw power, so the power at which we're throwing the axe, and again we can set this to 10F. And we're going to have one final public float here that we're going to call our axe rotation speed, so how quickly the axe needs to rotate when it's thrown, and we're going to set this to 10F again. And those are the basic three variables that we need in order to actually throw the axe. Okay, now we're going to need a reference to the collision script, so we're going to create another public axe collisions. I called mine new axe collision, so I have to reference it as that. axe collisions, and we can just call this axe collisions here. This is where things might get a little tricky if you've never used enums before. I've used enums in a previous tutorial for handling AI states, but we're going to use enums here to handle our axe states. So the axe will be in 4 different states. The first one will be static, the second one thrown, the third traveling, and the final one is returning. So each of those will determine which methods we're calling. So static, we won't really be calling anything, but that means that like the axe shouldn't be rotating if it's static. If it's thrown, then we're going to be calling like the throw axe function. If it's traveling, then obviously it needs to be rotating, so we'll be calling a rotation function. And if it's returning, then it does need to be rotating, and we want it to actually be returning to the player as well. So let's go ahead and define our enums. So we're going to create a public enum that we can call our axe state, and just use your curly braces here. Again, the first one is static, second one is thrown, third one is traveling, and the final one is going to be returning. Okay, now we do need a reference for our enum, so we're going to create a public axe state, and we can just call this axe state, and the axe state will allow us to reference it and change it as needed. Okay, the final couple of variables we're going to need are actually going to be private variables, and they will be used to handle the lerping of the axe when it's returning. So we're going to actually throw the axe using physics, but we're going to lerp the axe back to the player. Okay, and in order to do the lerp, we're going to need a private float start time, another private float that we will call our journey time. We're going to need a private vector 3 for our start position, and a private vector 3 for our end position as well. Okay, and that will do it for all of our variables. Like I said, there's a lot of them at the top of this script, so hopefully you guys made it through it okay with no issues. Now we can actually get into defining our functionality. The first thing we need to do is actually use our start function. In our start function, we need to set up the rigid body, and we are also going to set isKinematic to true, which means that the physics will not have an impact on the axe initially. And we are going to set use gravity to false as well. Again, if you don't do this, and your axe has one of those values like use gravity is set to true, then when you start the game, the axe is going to basically drop out of the player's hand, and we don't want that. We want the axe to seem like it's stuck in the player's hand. Okay, so the first thing we need to do is get our rigid body. So I'm going to say axe RB is equal to axe.get component, and we're going to get the rigid body component. Next, we're going to set axe RB equal dot is kinematic equal to true, so that way physics won't have an effect, and axe RB dot use gravity equal to false. Again, just to make sure that the axe doesn't fall out of the player's hand at the beginning of the game. Okay, now the next thing we actually need to do is change our update function to a fixed update function. We're doing this primarily because we're actually going to be using physics to throw the axe, and physics tends to work a little bit better inside of fixed update rather than update. So let's go ahead and remove that comment as well, since we're no longer using update. So the first thing that we want to set up is a check to see if we left click, which will be used to throw the axe. For now, we're just going to change the state of the axe to thrown. So what we're going to do here is we're going to say if input.get mouse button down, and we want the 0, which is a left click. And if that mouse button is down, then we want to set our axe state equal to axe state. Make sure you use the capital A here. Dot thrown. Okay, and you'll see why we're doing that in just a second. The next thing we want to do is actually set up a right mouse click to throw the to recall the axe. So right now we've got our left mouse click that will change the state to thrown, and our right mouse click that will recall the axe. So let's go ahead and define that. So we're going to say if, and we can actually copy the input.get mouse button down here, and just paste it inside and change the 0 to a 1, which will give us the right click. Okay, inside of this if statement, we need to do a couple of things. The first thing that we need to do is get some positions for our lerping function, like the starting and ending positions. So what we're going to do is we're going to say that our start pause is going to be equal to the axe.transform.position. So wherever our axe is currently at in the world is going to be the start position of our lerp, and the end pause is going to be equal to our axe temp holder dot transform dot position. So that's why that position holder, or the temp position holder, is so important, because we have to have it in order to actually get the axe to return to the exact same spot that we had it initially. The next thing we need to do for our lerp is actually set up our start time. So we're going to set our start time is equal to time here. And we also want to calculate the journey length. So the distance between the two vectors, which is just a vector3.distance. So we're going to say our journey length is equal to a vector3.distance. And we want to pass in our start position and our end position here. Now, the final thing we need to do here is actually change the axe state again. Obviously, we're going to change it to returning. So we're going to set axe state is equal to axe state dot returning. Perfect. Okay, now the next thing we need to do is actually check to see if our axe has been thrown. And if it has been thrown, then we're going to call a function, which we will set up in just a minute. Okay, and in order to check the axe state, all we have to do is say if our axe state is equal to axe state dot thrown. Make sure you use the capital T there. Then we want to call a function. And the function is just going to be called something very specific. I'm going to call it throw axe with physics. So that way we know exactly what we're doing here. So we're going to throw our axe with physics. Okay, so basically at the beginning, if we push or each update, if we push the left mouse button, it's going to change our axe state equal to axe state.thrown. And then we're going to check to see if the axe state is in that state of thrown, and if it is, then we need to call a function. All right, so we're going to set up that function a little bit later, but let's go ahead and continue with our fixed update for now. The next thing we're going to do is we're going to check to see if the axe is traveling or returning, and if so, we want to make the axe rotate or spin, because if you throw the axe without it rotating, then it looks, kind of goofy, because it's just an axe, just, stationary rotation flying through the air, which looks a little odd. Okay, so in order to do that, we're going to say if our axe state is equal to axe state dot traveling, or axe state is equal to axe state dot returning, then we want to do something. So basically what this is doing is just checking to see if the axe is in movement. So it will only be in movement during those two states, which means that if it's in those two states, then it should be doing whatever is inside of this if statement here. And what we want it to do is rotate, obviously. And it's pretty easy to do that. All we have to do is say axe.transform.rotate. And we can pass in, let's just pass in 6.0f multiplied by our axe rotation speed that we defined above, multiplied by time dot delta time for the x, obviously, and then we're just going to pass in a 0 for the y and a 0 for the z. So this is going to make the axe rotate on only the x-axis, which is pretty much what we want, because we don't really want the axe rotating on the z or the y, because if you think about how that's going to rotate, I mean, if you're throwing it at like a horizontal angle, so it's coming out of your hand while it's on its side, then you could have it rotate on the y, but we're just going to throw it, typical way of throwing an axe, to where the head is straight up and you throw it forward, which means it will rotate on its x-axis. Okay, now the final thing we need to do inside of our update function is we need to check and see if the axe is supposed to return, and if it is, then we need to call a function. So again, I'm just going to do one more if check here. So we're going to say if our axe state is equal to axe state dot returning, Then we need to call a function to make the axe actually return, and we can just call this recall axe. Okay, now let's actually get into defining these functions. The first one I'm going to define is going to be the throw axe with physics, because it's the first one we're calling here. So underneath my fixed update, I'm just going to create a little space here so you guys can see it more in the middle of the screen. In order to declare our function, all we have to do is call a void, because we're not returning anything, and say throw axe with physics here. We don't need any parameters, and we have to do several things inside of this function. The first thing that we want to do is make sure that the axe does not have a parent. If we don't do this, then the axe will still move around while the player looks around. So think about that. If it's underneath the main camera, which is being used for our look rotation and everything, then the axe will move while we move around, which is not what we want. We want the axe to move independently of the player once it's thrown. So in order to remove the parent, all we have to do is say axe.transform.parent is going to be equal to null. That easy. The next thing we need to do is make sure that our axe is in a traveling state. So we're going to say axe state is going to be equal to axe state.traveling. Now we also need to change the values of is kinematic and use gravity, because we do want physics to have an impact, and we also want gravity to have an impact on our axe now that we're going to be using physics to throw it. So we want to say axe rb.is kinematic equal to false. So now physics should have an impact, and our axe rb.use gravity is going to be equal to true. So now gravity will also have an impact on our axe as well. Now the final thing we need to do is actually throw the axe with physics, which is again pretty easy to do. All we have to do is say axe rb.add force, and we're going to add it on the axe.transform.forward. We're going to multiply that by our axe throw power. So that's all we have to do for this function. We're doing quite a bit inside of one function, but we have to do all of this in order to actually get the axe to work. Now, the next thing we need to do is create our recall axe function. So what we want to do here is say a void recall axe. And inside of this function, what we want to do is lerp the axe back to the player's hand. So we're going to need the distance that we've already covered and the fraction of the journey that we've already covered as well. We're going to create a float dist covered is going to be equal to our time, parentheses, time.time minus the start time multiplied by our axe flight speed. And we're going to need a float frac journey. We're going to set that equal to our distance covered divided by the journey length. And finally, we're going to update the position, which is going to be axe.transform.position. It's going to be equal to a vector3.lerp. And we're going to pass in our start position, our end position, and our frac journey here. Very simple. We've covered lerp a lot in a lot of different videos, so I'm not going to dive into it deeply here, but just know that's what we need in order to recall the axe. Now, we do have to do one final thing inside of this function, and we want to check to see if we've completed our journey, and if we have, then we're going to call another reset function. And you'll see why the reset function is really important in just a minute. Okay, so what we're going to do here is say if our frac journey is greater than or equal to 1.0f, then we want to call our recalled axe function, which is basically going to be used as a reset function, which means that we're going to reset a lot of values and change the state inside of this other function. Okay, now let's go ahead and define our recalled axe function. Again, we're not returning anything from here, so we can just call it a void recalled axe. Don't need any parameters. And really, this is sort of a management function, which means that we're going to just be using it to update a lot of different values. So the first thing we're going to update is going to be our axe state, and we're going to set that equal to axe state dot static. So we're making sure that our axe is returning to its static state. Then we want to remove the constraints, which is the really important function that we defined inside of the axe collision script, as you may remember. So we're going to say axe collisions dot remove constraints. And now we actually need to complete a hard reset of the position and rotation of the axe back to the initial settings. So right now we're not actually calculating like a rotation or position based on the lerp. Really all the lerp is doing is moving us back towards the player, but it's not creating an exact position and rotation at the end of it. And we definitely want it to have that exact positioning and rotation once it gets back to the end, or every time you recall the axe, you could have something different. So in order to do that, we're going to set our axe.transform.position equal to our axe temp holder dot transform dot position, and we're going to set the axe.transform dot rotation equal to our axe temp holder dot transform dot rotation. So very simple, but it's very important too that we actually do that. And of course we have to change is kinematic and use gravity again. So we're going to say our axRB is going to be, our axRB dot is kinematic is going to be set back to true. So physics will no longer have an impact, and axRB dot use gravity is equal to false, which will remove the impacts of gravity on the axe again. Now we do also have to reparent the axe, or else the axe will not move with the player. So we're going to say that our axe.transform.parent is going to be equal to this.transform. So it's going to be parented to whatever object that this axe script is actually placed on. Okay, now we need to define that final function of collision occurred. So as you may remember, we defined, or we had a call to that inside of new axe collisions, which gave us an error in Unity, but we're going to go ahead and actually define that here. So what we're going to do is create a public void. It needs to be public so that the other script can call it. And we're going to say collision occurred. Okay, and all we're going to do here is set our axe state equal to axe state dot static. And that's really important because you want it to stop rotation on collisions. And if we didn't do this, then it would continue to rotate once it reached a collision point. Okay, now let's go ahead and save that. Let's go back out to our script here. Oh, looks like I've got an error. Name journey length does not exist in the current context. Oh, I called it the wrong thing here. Sorry about that, guys. I called it journey time up here, but we need to call it journey length. There we go. That took care of most of our issues. Now we've got one on remove constraints. Okay, of course. I did not create these as public functions here, so we need to go ahead and convert these to public so that we can call them from other scripts. All right, now we've got an issue. The dot operator cannot be applied to operand of type method group. Oh, yeah, this should be rigid body constraints, not remove constraints. There we go. That took care of all of our issues. That's great. Now we need to just finish wiring up the axe. So just add the scripts to the axe as needed. Now we're actually going to add the axe script to our main camera. So let's just go to the main camera, and we can just drag the axe over like that. Toggle it down. Obviously, we're going to have to set up a couple of public variables. But let's go ahead and add the collisions to the actual axe game object here. So I called mine new axe collisions. You probably called yours axe collisions, but just drag it in and drop it. Of course, this is going to be getting the rigid body on start, so we don't have to worry about dragging that in. But if you want to, you can obviously drag it in. We're going to be passing the main camera as our axe here, or as our reference to the axe script here. Now, inside of our main camera, we're going to need a reference for the axe game object, so we'll just drag our axe in here. We're going to need a reference to the rigid body. Again, we can drag it in, but it should get it on start. We need a reference for our temp holder, or our position holder. And now we're going to need a reference to the axe collisions again as well, so we can just drag in the axe again, and it will get the script off the game object for us. And as you can see here, it's got our axe state set to static at the beginning. Okay, now we do have several variables set here, the flight speed, throw power, and rotation speed. And I'm actually going to look at my previous example in order to get the initial values for this. Of course, you can play around and test these values and mess with them however you want, but I just really played around with them a lot myself, so I'm gonna go ahead and copy over the values that I have, and I'll be sure to show them on screen as well. Okay, so if I just look at my main camera over here, I've got values of 30, 1500, and 200. So let's go ahead and plug those in. For our flight speed, I've got a value of 30, for the throw power, 1500, and for the rotation speed, a value of 300? Was that 300? 200. I was close. So that should be all that we need here. So let's go ahead and actually test it out to make sure it worked. Of course, save your work ahead of time, and now let's press play and make sure it doesn't explode. Okay, so now we're in our world here. I can left click throws the axe. Of course, it travels away from us and it sticks where it lands. Obviously, it's not always going to stick with the axe blade in first. That would be something that we would work on with a more polished version. Now let's go ahead and try recalling it. So right click, it recalls to us. Okay, let's try it again. Throw, boom, and recall. All right, now let's try throwing it really far away. And this is actually an interesting bug that I found as well. It didn't actually leave the arena. Let me make it leave the arena really quickly. So just toss it out of the arena. And now if I recall it, you'll see that it stops. Like if I look at the axe right now, you'll see that it's frozen, but it should be returning to us, right? I'm going to take a quick second, see if you know what the problem is. So go ahead and pause it and try to figure out what the issue is here. Okay. So the answer to this little issue is that we're actually never turning off the collider or making the collider a trigger. So it is actually colliding with the wall outside. So if I go out here and look at my axe, you can see that it has collided with the outside wall while it was trying to return to us. So in order to fix this, all we would have to do is turn off the collider while the axe is returning. So it's not that big of a deal to fix. Okay, now if you do click again, right click again, then the axe will actually return to you. Very cool. So now we've got this pretty much working like we wanted. Boom. Nice. Whoop. See, and that's another one of the bugs. Of course, that's one that if you guys can figure out, I'd love to know sort of what you guys think is causing this issue, is that every once in a while, the axe returns and doesn't make it all the way back or makes it back a little bit too far. I'm at a perfect angle here to chunk it right into the wall. Very cool. Okay guys, that's going to do it for this video. If this video gets 50 or more likes, then I will create a polished version of the axe where we can start playing with things like Bezier curves to throw the axe on a curve or return on a curve. We can fix a couple of the bugs that already exist and just make everything a little more pretty with like trail renderers and things like that as well. Definitely be sure to drop us a like and of course subscribe if you're not already. We're working on a lot of new videos. Darren's working on a new UNet series that is being completely driven by the community, so I'm sure you'll enjoy that one as well. Thanks for watching.